All right, let's talk about your next software engineering interview. You're almost guaranteed to get asked about design patterns. So today, we're going to break down one of the most fundamental ones, the singleton. Honestly, mastering this is a huge step toward acing that technical round, so let's just dive right in. So let me just ask you this. Have you ever been coding and suddenly realized, wait a second, I need to make absolutely sure that for this one class, only a single object ever gets created? This happens all the time, right? Think about things like a system logger, a configuration manager, or anything that talks directly to a piece of hardware. Well, for that exact problem, there's a really classic, elegant solution, and that is the Singleton Design Pattern. It's literally built to do this one thing and do it perfectly. So what is it exactly? Okay, if you're going to remember just one sentence for your interview, make it this one. The Singleton pattern ensures a class has only one instance, and, this is key, it provides a single global point of access to that instance. That's it. Two simple parts, one instance and one way to get to it. To really make this stick, let's use a real-world analogy. Just picture you're in an office, right? You've got tons of people all working away on their computers. And all of these people, they all need to print stuff. Now, is the office going to buy a separate printer for every single employee? No way. Of course not. That would be a total waste of money and space. Instead, everyone connects to one central shared printer. And that printer, that's our singleton. It's a single, shared resource that everyone has one global way to access. Okay, so the analogy makes sense. But how do we actually build this thing in our code? Let's break down the right way to do it by first looking at what not to do. So the bad approach, that's just letting any old part of your code create a new printer whenever it wants. You'd end up with multiple printer objects all trying to talk to the same physical hardware. And, well, that's just chaos. The good approach, the singleton way, makes sure only one single instance is ever created. This gives you controlled, predictable access. The whole pattern really just boils down to three clever little tricks working together. First, you make the constructor private. This is like putting a lock on the door, so no one can just create new instances on their own. Second, the class itself holds its own single static instance. And third, you have a public static method, usually called getInstance, that acts as the one and only gatekeeper. It's the only way to get the key to that single instance. And here's a quick peek at what those pieces look like in C++. You can see the static instance pointer right there. And the getInstance method, yeah, that's where the magic happens. Inside that function, you check if the instance has been created yet. If it hasn't, you create it. If it has, you just return the one that already exists. This simple structure is what guarantees you only ever make one. Now, that basic implementation is great, but it has a hidden weakness in modern apps. If you want to go from giving a good interview answer to an outstanding one, you've got to talk about thread safety. This is the pro move. Think about it. What happens if two different threads in your program call getInstance at the exact same microsecond? Uh-oh. They might both check if the instance exists, both see that it's null, and then both try to create a new one. All of a sudden, you've got two instances, and your whole singleton pattern is broken. This is a classic interview trap. Seriously, interviewers are often looking to see if you can spot this potential race condition. Just giving the most basic singleton implementation without mentioning this weakness, that's a really common mistake. So how do you fix it? Here's the pro tip. After you explain the basics, you proactively bring up thread safety. And the key term you want to drop is double-checked locking. It's just a fancy way of saying you check once without a lock for performance, and then, only if you need to, you acquire a lock and check a second time before creating the object. Mentioning this shows a way deeper level of understanding. Okay, let's zoom out for a second and just quickly recap why this pattern is so important, and also touch on a few things you need to be careful about. So, why do we bother with all this? Well, the benefits are pretty huge. You get controlled access to that one object. You guarantee resource efficiency. Like, you don't want 100 different open connections to your database, right? You want one managed connection pool. And finally, you get a super convenient global access point from anywhere in your code. But, and this is a big but, you have to be careful. We've already hammered on the biggest mistake, forgetting thread safety. The other major trap is overusing the pattern. Because a singleton creates a kind of global state, it can make your code really hard to test in isolation. So you want to use it wisely and only when you truly need that single shared resource. All right, we have covered a ton of ground. So let's just boil it all down into the perfect final takeaway for your next interview. When the pressure is on and your mind goes blank, just remember these 4 words: one instance, global access. That's it. That's the whole game right there. Everything else is just how you make it happen. So when that interviewer looks at you and asks, "Can you define the Singleton pattern?" you can bring it all home by confidently saying that core definition we started with. It's simple, it's precise, and it shows you totally get the pattern's fundamental purpose. And that's the Singleton pattern, completely demystified for your next interview. If this was helpful and you want to break down more design patterns, make sure to subscribe and follow the series. Thanks for watching, and happy coding.